we will take today mesomeric effect under bond polarization. Mesomeric effect is the effect of groups or atoms which bring about polarization in the system. This effect propagates through pi electrons. And is a permanent effect, bringing about polarization in the molecule. You had seen earlier in inductive effect that it was through sigma electrons, single bonds. That was also a permanent effect. First, we will see this plus M effect. Plus means the groups are atoms which push away electron density from themselves. Minus means the effect the groups which pull electron density towards themselves. When it is plus M effect, you find that all these groups or atoms have an electron pair, lone pair of electron pair on them except methyl. Here you see that all have multiple bonds here, N double bond O, C triple bond N, S double bond O, and this double bond. We will first take now plus M effect. One example, say if OR is attached to this conjugated system, then as you know, we can write these resonating structures for this. You know all very well how to write these structures. In the resonance hybrid, there will be plus charge, slight plus charge on this O, slight negative charges on this and this carbon atom. So, this is an effect due to alkoxy group. This brings about this type of movement. So, that is why it is called the effect of a group, because this pushes electron density away from itself. This was plus M. Take one more example. Phenoxyanion. This all you can write. This is the hybrid of all these 5 structures. This movement of electrons which you are seeing is due to this oxygen atom having electron pair here. it pushes electron towards the double bonds. So, this is a plus M effect of oxide group. Similarly, you can write the structure for all these because they have electron pairs here. As regards this methyl, you remember hyperconjugation, in which this alkyl group, this methyl group is attached to the pi system. This is hyperconjugated with this double bond. So, you can write these structures. No bond resonance. I have already explained in the earlier video. You find here that a plus charge is created in this hydrogen atom and a negative charge on this carbon atom of the ring. You can write all other structures by moving it here and so on, and then with this hydrogen and then with this hydrogen, total 11 structures. So, 9 more. I am not writing here all those. So, this creates a negative center at ortho position of it, para position and ortho position. So, methyl group has a plus M effect, creating negative centers in the molecule at ortho and para positions. We have taken thus all these cases. You can write structures for all these again. As regards minus M effect, if you look at this group C double bond O, a multiple bond having dissimilar atoms, that is of different electronegativities, the tendency here is of this polarization. This pi electron pair moves over here, forming this type of structure, a plus charge here. So, carbonyl group is a hybrid of these two structures. Resonance takes place here, and we generally write it as delta plus, delta minus. The carbonyl carbon atom of is slightly positive charged. When this type of groups which have multiple bonds having similar situation attached to pi bonded system, they withdraw electron towards themselves because of this tendency. I will take one example of say CHO. This movement. So, this is the effect of this CHO, that the electrons are coming out of the ring. It is attracting. And so on. You can write all these structures. Etc. You find that this group has created positive centers in the ring. a polarization has taken place. So, this is the effect of this group, that this type of movement has taken place. You can write similar structures for all these, because they are all multiple bonds. I have given you here the order of decreasing tendency. Here again decreasing tendency. We will use these two effects in describing orientation in electrophilic substitutions in the ring later when we will take that. Okay.